So hi guys, today we are going to be solving the problem C product of Atcoder beginner contest 2033. So let's look at the problem statement first. We have n bags. Bag I contains Li balls. The jth ball in bag I has a positive integer aij written on it. Alright. We will pick out one ball from each bag. You know? How many ways are there to pick the balls as that the product of the numbers written on the picked balls is x. Here we distinguish all balls even with the same numbers written on them. Okay, so basically what the question is that you will be given n bags, and every bag is going to contain some Li balls. Ith bag will have Li balls, and every ball in every bag will have some positive integer written on it. Okay, aij, something will be written on every ball of every bag. Okay, now what we have to do is we have to pick n balls. Why n balls? Because it is stated that we'll pick out one ball from each bag. We'll pick one ball from each bag, and at the end we just need to tell the number of ways such that after picking n balls out of the total balls, where one ball is picked from every bag, the number of ways is that the product of these n numbers is equal to x. So let's just simplify it. What we have to do is we have n bags, right? N bags, and we have to pick one ball from each bag, right? And at the end, we need to tell the number of ways such that since we are picking up one ball from each bag, right? So total number of balls that we'll pick is n. So we just have to tell the number of ways such that the product of these n numbers is equal to x. That's it. That is the question, right? So if you look at the constraints, here it is given that n will be greater than or equal to 2, but no upper bound is given here. Li will be greater than or equal to 2, okay. And it is given that the product of the number of balls in the bags is at most 10 raised to power 5. This is the most important line of this problem, right? If this line was not given here, then this would have been like very tough to solve. But this line simplifies the question so much. How? We will talk about it. And these are just general constraints, no worries. They are just telling us that we have to use long in place of int. Okay, so so first of all, let's just think about the brute force solution. What would the brute force solution look like for this problem, right? So what would I do? I would first iterate on, you know, okay, let me just shift to VS Code. Okay, I think that will be better. All right. So what I would do is I would just iterate on all the balls. Suppose the number of balls in first bag is L1. Then I will iterate on all the balls of the second bag. Let's say L2 is total number of balls in the second bag. Then I'll iterate on bag 3, all the balls on bag 3, and so on, right? So on. Okay. So if you look at this loop, this solution, and observe it, then you will see that it is just the brute force solution. But here some other factor is also coming in. What? The number of bags that we have. For that we will have to uh, do another loop here, because we don't know how many bags we are going to get in the input. I hope this is clear, right? We don't know how many bags we are going to get in the input, so we do not know until when we should nest loop, because like it would depend upon the input, right? The more the number of bags, the more is the number of nesting, right? So we do not know, right? But one more thing that you should see is, suppose by some miracle we do not have to worry about the number of bags, right? We can just do this and our answer will come out. So you need to see that the time complexity of this, only this code, and it is nested n times, okay, and minus 3 times inside, because I have put 3 loops above. So the time complexity of this loop, it is going to be L1 into L2 into L3 into L4 up to into Ln, right? I hope this is clear, right? Because there are n loops nested within one another, the time complexity is going to be this, right? Now it is given that this product is never greater than 10 raised to power 5, right? It is at max 10 raised to power 5, which means that even if we are able to solve our question in this time complexity, our answer will come, right? Like our answer will come, there will be no problem. But the only problem is that I do not know the number of bags, and how would I incorporate them in iterative way? Right? How would I take care of these the number of bags here? So to rescue us from this situation, recursion comes into play, right? And that is it. The most important hint for this problem is recursion. Since everyone is able to think about this solution, this is the brute force solution, but able to think about this in the recursive way solves the entire problem, right? So when we are doing recursion, we can maintain two variables. Okay, with one variable will be the current value of x, okay, and another variable will be the current bag from which we are interested in picking up the ball, right? So here you after using recursion, we can keep track of the number of bags that we have covered, and we would not have to give extra time or extra loop for it, right? Okay, so like it would be more clear when you look at the sorry, when you look at the answer. So here what I'm doing is uh, first of all, I'm taking input here. I have made n and x as global so that I can use it in my recursion, and then I'm here also I'm just taking the loop in my vectors of vector, and here I go to the solving part. Now what do I do? This first statement is the base case. What does this state? It states that if I have covered all my bags such that if my I has become equal to n, that is I have covered all my bags from 0 to n minus 1, then the n numbers that I have picked, that is a valid, like you can say a valid collection only when x is equal to 1 after dividing x by the product of these n numbers. That is correct, right? Correct. So if at this point my x becomes 1, that means that all of the numbers that I have picked, they are valid. They are making a sequence that is uh, whose product is equal to x, right? Now here what I am doing is I am initializing my answer as 0, and I am iterating on every ball in my current bag, that is for every jth ball in my ith bag, right? So what I am doing is I am checking that if my current ball, that is jth ball in my ith bag, whether it divides x or not. If the modulus of x via v of ij is equal to 0, that means I can put this in my current collection, because suppose it was not even dividing x, then there is no sense of putting this ball in the my my collection, current collection, right? So what I would do is I would update my answer as answer. That means that the number of ways that I have found out till j minus 1, plus now I will go to the second bag, like second by second means to the next bag, right? Because I only have to pick one ball from each bag, and I will divide my x by the value of the ball that I have picked currently, which is v of ij, right? And at the end I will just return the answer. So at the end it will return me the number of ways by which I can pick one ball from each bag such that the product of these n chosen balls is equal to x. Now if you want to look at the time complexity of this approach, you can easily see that it is just mimicking this. It is just n loops nested within one another, and the time complexity is going to be O of you know L1 into L2 into L3 into dot 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 into Ln, right? So that's it. Let me know if you have any doubt here. I think the biggest observation for this problem was that you can use recursion here, nothing else. If you got the idea that you can use recursion, then this problem was really a cakewalk problem. Okay, if you have any kind of doubt, then you can let us know in the comment section. Thank you for watching. Please like and subscribe if you liked the video.